This is Chapter 4D, Parsing the Problem, and here we're going to talk about Step 1, Defining the Populations. So throughout the remainder of this semester, we're going to be working with 5 steps of hypothesis testing. And in this lecture, we're talking about Step 1, Parse the Problem. I call it Parsing the Problem, and it's just describing exactly what the problem is asking. So let's consider Problem 1. Jordan wanted to test the hypothesis that people who wore masks would violate more rules than people in general. So first we're going to define what we'll call population 1. And this is the population of interest to the researcher or the group of people the researcher thinks will be different in some way from other people. We'll apply this to problem 1 on the next slide. I'm just defining these populations for right now. Population 2 is the group of people the researcher is going to compare her people to. And in this chapter, it's always going to be some sort of a general population. We're always going to compare the people of interest to a general population. The dependent variable is the next thing we'll describe, and that's just what is being measured. Whatever trait, characteristic, or behavior the researcher thinks will be different about population 1. So it's just the name of a variable. Next, we'll be describing directionality, or the direction and the tails of the hypothesis. So does the researcher have a prediction that the dependent variable will be greater or less than population 2, or just that population 1 will be different in some way from population 2? Look for directional words like more, less, or words ending in ER like greater, less, greater, lower, something like that. If it's a directional hypothesis, you'll use a one-tailed test. If it's non-directional, you'll use a two-tailed test. And you can see the one-tailed test with a high hypothesis is in image 1, with a low hypothesis is in image 2, and image 3 has a two-tailed test. In the research hypothesis, we just state that population 1 will have, and then we state the direction, whatever we wrote here, then we state the dependent variable, then population 2. We'll look at this again from this problem on the next slide. And the null hypothesis, we're going to just rewrite the research hypothesis, except we're going to add the word not to the problem to suggest that there's no difference. So now applying what we just said to this problem. So first off, population 1 is just people who wear masks. That's who Jordan thinks is going to be different in some way from other people. Population 2, who are we comparing these mask-wearing people to? Just to people in general. What are we comparing? Well, it says they will violate more rules. And so I would say it's not stated directly in this problem, but I'm going to call it rule violations. Jordan thinks that the number of times people violate rules will depend on whether or not they're wearing a mask. That's why we call it the dependent variable. The direction and tails, well, this is directional. And I know that because of this word more. This word more suggests that we are going to have a one-tailed test. And it's also going to be a one-tailed high test, meaning that we'd be looking for the people who wear masks to have the number of rule violations somewhere up in this tail as shown in image 1. The research hypothesis is that people who wear masks, population 1, will have more rule violations than people in general, which is population 2. And the null hypothesis, here we add that word not. People who wear masks will not have more rule violations than people in general. Going on to problem 2, let's do another one. Collier suspected that people who drank 2 alcoholic drinks in the evening would have greater anxiety in the morning than the general population. Population 1, then, is just these people who drink 2 alcoholic drinks in the evening. Population 2 is people in general. The dependent variable is morning anxiety. The direction and tails, well, this is one-tailed high. We can see because of this word greater in the problem, so we'd be looking for this image 1 again. Whoops. And the research hypothesis, which we can shorten to read H1 or else HA, because sometimes we call it the alternate hypothesis, we would read population 1, which are these people who drink 2 alcoholic drinks in the evening, will have higher anxiety than population 2. And our null hypothesis, people who drink 2 alcoholic drinks in the evening will not have higher anxiety than population 2. So now we've parsed another problem. Problem 3. Dr. Athelstein believed that people with arachnophobia who watch cartoons of friendly spiders would have different levels of spider anxiety than the general population of people with arachnophobia. So population 1 is the people with arachnophobia who watch cartoons of friendly spiders. And who are we comparing them to? People with arachnophobia in general. So notice that population 2 is a little different now. We're not comparing people with arachnophobia who watch the cartoons with people in general, but it's specifically people with arachnophobia in general. The dependent variable is spider anxiety, and I know that this is a two-tailed test, or image 3, because of the word different. And you can see the research, the alternate hypothesis, H1 or HA, is that population 1 will have different levels of spider anxiety than population 2. And the null hypothesis is that population 1 will not have different levels of spider anxiety. Here's another one. Officer Warren believed that people who viewed videos of car accidents would drive at slower speeds than the general population. So population 1 are these people who watch videos of car accidents, and population 2 is the general population. The dependent variable is speeds, miles per hour, and the direction is one-tailed low. I know that because of the word slower, and so we'll be looking at image 2 to solve this problem. The research hypothesis, H1 or HA, is that population 1 will have slower speeds than population 2, and the null hypothesis is that population 1 will not have lower speeds than population 2. And one last problem, problem 5. Dr. Apple thought that people who lived within 1 mile of a store with affordable fresh vegetable options would eat more vegetables than people in general. And so we're comparing population 1, people who live within 1 mile of a store with affordable vegetable options, with population 2, people in general. The dependent variable is vegetable consumption, and the direction in tails is one-tailed high, and I know that because of the word more, so we'll be looking at drawing image 1. The research hypothesis, population 1 will consume more vegetables than population 2, and the null hypothesis is that population 1 will not consume more vegetables than population 2. Now go ahead and take the practice quiz that's associated with parsing the problem.